All right, so in this example, Cantwell Associates is going to be building a new apartment complex consisting of 1 bedroom, 2 bedroom, and 3 bedroom townhomes. They want a total of 192 units. Total of 192 units. So let me underline that. That's kind of critical information. And the number of family units, so they're considering family units to be 2 bedroom and 3 bedroom homes, will be equal to the number of 1 bedroom homes. All right. So, and then the number of 1 bedroom units is 3 times the number of 3 bedroom units. And we want to find how many units of each type will be in the complex. All right. Well, there's just a lot of words, so let's let's try to decipher all these words and turn them into equations. That's the critical thing. So first of all, I'm going to assign some variables, right? So, like for example, this first equation or this first piece of information that says that the total number of units is 192 means that I have to know the number of each type of unit. So what I'm going to do is just make those my variables. So I'm going to let x be the number of 1 bedroom units. Okay, 1 bedroom units. I'm going to let y be the number of 2 bedrooms, 2 bedroom units. And then z, I'll make that the number of 3 bedroom units. All right, so now that I have some variables defined, now I can write some equations. So the first piece of information was just saying that the total, we want a total of 192 units. Okay, so that's just telling me that x, the number of 1 bedroom units plus the number of 2 bedroom units plus the number of 3 bedroom units is 192. All right, that's pretty straightforward. Now we just need to go back up to our paragraph and find out the next information. So that's the first piece of information. The second piece of information is this whole thing here. The number of family units, which is the 2 bedroom and the 3 bedroom, will be equal to the number of 1 bedroom units. Okay, so 2-bed, oops, that's not a B, 2 bedroom units plus 3 bedroom units is equal to the 1 bedroom, the number of 1 bedroom units. Oops, oh my gosh. Bedroom units. Okay, so that's kind of how it looks in words. But, so my 2 bedroom units, that's y, that's the number of 2 bedroom units, plus the number of 3 bedroom units has to be equal to the number of 1 bedroom units. So that's how I can write it as an equation. All right, and then let's look at the last piece of information. The number of 1 bedroom units will be 3 times the number of 3 bedroom units. So 1 bedroom units, 1 bed, is equal to 3 times the 3 bedroom units. 3-bed. Okay, so if we write that as an equation, essentially what we have is number of 1 bedroom units is x, and that's going to be 3 times z, which is the number of 3 bedroom units. All right, so now we have 3 equations. If we've used all the information in the paragraph, we have 3 equations and 3 unknowns. So now we can try to solve that system of equations. We're looking for a value for x, y, and z that satisfies all of those equations. All right, so let's do that. Now, one thing that will help us, if I need to rearrange these equations a little bit. Now, this first one's okay because we have x plus y plus z equals 192. That's the same as 1x plus 1y plus 1z equals 192. So I want to write a system of, I want to write an augmented matrix because I'm going to solve this with Gauss-Jordan elimination, right? So that's pretty easy just to write the first row as 1, 1, 1, and 192. Okay. But to create this augmented matrix, I need to have all the variables on the left-hand side and then the constants on the right-hand side. I need a constant on the right-hand side. So I need to rearrange this equation, the second equation, right? Y plus z equals x. If I just subtract x from both sides, what I get is minus x plus y plus z equals 0, right? That's the same equation. I've just added I've added a negative x to both sides. So that's the same as negative 1 times x, 1 times y, and 1 times z. So my coefficients are negative 1, 1, and 1, and that's equal to 0. Okay, so I'm just putting these equations in the form I need so that I can write my augmented matrix. And this last one, I need all the variables on the left-hand side. So I'm going to subtract 3z from both sides. So I've got x, I don't have any y values at all, and then we have minus 3z is equal to 0. Okay, so there's no y value, so I could write this as 0y if I want to, right? 1x plus 0y equals negative 3, or sorry, minus 3z is equal to 0. So my coefficients are 1, 0, negative 3, and the right-hand side is just 0. So now I have an augmented matrix, and I can do Gauss-Jordan elimination on it and get the solution that way. All right, so think about my goal. My goal is to get this row reduced form, right? I want it to be in this form. I want it to be 1, 0, 0, 0, 1, 0, 0, 0, 1, and then some numbers over here. Okay, that's my goal. Okay, so I'm just going to keep that in the back of my mind. That's what I'm going for. Now, when I looked at the first column, that looks good. It looks pretty good. I got a 1 where I want it, and now I just need zeros below it. So if I take row 2 and just add row 1 to it, that'll give me a 0 where I want it. And I can also take row 3 and subtract row 1 from it. And that'll also give me a 0 down in the third row in the first column. All right, so let's do that. Let's do both of those things. So I'm not going to touch the first row at all. I'm just going to copy it down as it is. And then when I add the first row to the second row, so 1 plus negative 1 is 0. 1 plus 1 is 2. 1 plus 1 is 2. And then 192 plus 0 is 192. Okay, that gives me the 0 where I want it in the first column. And now let's do the other row operation, which is to subtract row 1 from row 3. So 1 minus 1 is 0. 0 minus 1 is minus 1. Negative 3 minus 1 is negative 4. And 0 minus 192 is a negative 192. All right, so I've taken care of the first column. And now let's move on from there. What do I want to do next? I want the second column to have a 1 in the middle and zeros above and below. Now I can see that everything in that second row is even. So an easy thing to do would just be to take 1/2 of row 2. And that also gives me a 1 in the middle, right? And I can do that without dealing with fractions. So let's just do that. So let's just take that little baby step. I'm not doing anything to row 1, leaving that as is, and I'm also not going to change row 2. Although I could take the negative of all of those, but I'm just going to leave it as it is for now. Negative 4, negative 192. And I'm only going to change row 2, and that becomes just dividing by 2. I get 1, 1, and 96. Half of 192 is 96. All right, so I got a 1 in the center where I want it. It's in that second column. So now I just need zeros above and below it in that second column. So I can see that if I just take row 3 and add row 2, that's seems like a good thing to do, right? That'll get a 0 where I want it. And then I can actually take row 1 and subtract row 2. Okay, and that'll give me the 0 in the first row, second column. All right, so let's do that. All right, let's work on the first row at first. So I'm going to subtract row 2. So 1 minus 0 is 1, and then 1 minus 1 gives me 0. 1 minus 1 gives me another 0. 192 minus 96 is 96. Okay. I'm not going to do anything to the second row, leaving that as it is. 1, 1, and 96. And then I need to take row 3 and add row 2 to it. So 0 plus 0 is 0. 1 plus negative 1 is 0. 1 plus a negative 4 is negative 3. And then 96, or negative 192 plus 96 gives me a negative 96. All right, I've got the second column taken care of. Now I just need to take care of the last row. Okay, take care of the last column, right? Well, I can take care of the last row too, really, because everything looks good, and the only one that needs to be a 0, I need a 0 right here, where instead of a negative 3, I need a 0. But I'm seeing first that it probably just would be easy to just divide, take 1/3 of row 3. So I'm just going to take that little baby step, because if I take baby steps, I'm less likely to fall down. So, well, yes, I'm just going to divide that by, multiply by 1/3. So I'm not changing anything in the first or second columns. So I'm going to, this is 96. This is 96. And I'm just going to divide by 3. So 0, 0, or negative. Oh, maybe I should do negative 3. Well, I want that to be 0. No, I want that to be 1, right? So let's just make it, let's make this a negative 3. And then I'll get a 1, right? Because I want that lower right-hand corner to be a 1. And if I divide negative 96 by negative 3, I get a positive 32. Okay. One more step. I need a 0 in the second row in the last column. Okay. And what I can do is just take row 2 and subtract row 3. That's my last step. And then I'll have it just the way I want it, right? So then I've won the game. I've won the game of Gauss Jordan. All right, so I'm not changing the first row at all. And I'm going to take row 2 and subtract row 3. So 0 minus 0 is 0, 1 minus 0 is 1, and 1 minus 1 is 0. 96 minus 32 gives me 64. And then I don't need to change the last row at all. 32. And voila, there we go. We've got our solution, right? Now, if I just take this augmented matrix and turn it back into a system of equations, I've got 1x plus 0y plus 0z is equal to 96. I've got 0x plus 1y plus 0z is equal to 64. And I've got 0x plus 0y plus 1z is equal to 32. So that's my solution, right? So that's how many 1-bedroom, 2-bedroom, and 3-bedroom apartments, right? Because that's how I defined my variables. So we're going to have 96 1-bedroom apartments. We're going to have 64 2-bedrooms and 32 3-bedroom apartments. Now we can always check and make sure that that works. I always recommend checking. It's easy enough just to plug in the numbers and do the arithmetic. So I want the sum of all of the units to be 192, right? That's what we said we wanted. So if I add these up, let's just check. Does that, 32, does that add up to 196 or 192? And it does. If you add that all up, it should be 192. So that checks out. We also wanted what? The number of 2 bedrooms plus the number of 3 bedrooms to be equal to the number of one bedrooms, right? So 64 plus 32, we want that to be equal to 96, right? And that works out. And then we wanted the number of one-bedroom apartments to be 3 times the number of 3-bedroom apartments. So 96, we want 96 to be equal to 3 times 32. And that also works out. Okay, so we can check it all. Everything satisfies our equations, and so we're set. That's our answer. So this is our final answer right here. All right, we got one more example here, and this is one you should just try on your own. Give it a try, and then watch the video if you want to go through it with me.